Thanks, Ben. So I think this presentation follows on very nicely from Assen and Philip. We're another double act. And we're really looking at applying some of the principles. I've have the pleasure and benefit of working in Leader as well, so I'm able to track and understand and get taught a lot of these linked data guidelines and best practice and participate in those. But we're specifically involved in the FALCON project and trying to apply them in the localization industry. So it involves ourselves at the Adapt Center at Trinity College, Andy Way's Machine Translation Group at DCU and Adapt, but also three vendors from the localization world, Andy Zydron's company XTM, Development Technology who do terminology management, and EasyLing that produces a website translation system. And what we're really doing is testing how far we can go with linked data and what are the benefits of it in a state-of-the-art localization tool chain. And what we're trying to aim in doing that is something we sort of referred to as the localization web. So we're trying to see how can we take ideas of linked data on the web, so the benefits that we have, that we just heard about in Leader, so fine-grained interlinking between resources, extensible metadata, standardized query APIs, and apply them to localization, where we already understand the language resources that we use, particularly translation memories and term bases, and make them linkable resources, and also see how can we add more value to those resources, especially taking notice and making use of metadata that tends to get generated in the localization process and in localization tool chains, but tends not to be published at the end of the day when those projects finished. And finally, how can we use that technology to improve the dynamic training of language technology components, so specifically machine translation and automatic term extraction. And we really have this vision of trying to bring together the world of linked data and the problems faced by localization industry to really build up what we call the localization web, a decentralized, annotated global translation memory and term base, which I think fits in very well with some of the vision that's being talked about in the Connecting Europe facilities next door. So where are we at the moment? So at the moment there is, obviously there's lots of parallel data on the web. Web content gets translated. So here's an example actually of the DGT website. It's some legislative content, and you can actually, they're actually starting to provide URIs right down to the paragraph level. But when we talk about this as a resource that we want to use, we're really interested in the parallel sentences. That's what we use for translators in translation memories, and also what we use when we're training MT engines. So that's there. It's not linked directly from the web page, but fantastically we can go to the Open Data Portal and get all of the translation memories that correspond to these documents, actually quite nicely archived corresponding to these individual documents. What we also have from the EU in this context is the Euro vocabulary. So the vocabulary that they use, the multilingual vocabulary that they use in actually doing those translations. So we can look at that sentence, and there was a word there that talked about production capacity. And one of the things we could do is look in this resource and see that there's a definition of it. There's some semantic information pointing to more general, more specific terms, and also translations in multiple languages. So we already have a resource that we sort of know is implicitly connected, but can we make that connection a bit more explicit using linguistic linked data? But what we're also really aware of is, what we've heard again over the last few days, the sort of resources that are being pulled together in platforms like BabelNet and BabelFi, where we're getting a lot of conceptual and multilingual lexical information and providing that as services. So the sort of things we can now do is, if we're going to translate a sentence like that for the first time, we can run it through the service BabelFi, and that does a pretty good job at identifying words in there and providing us additional information, including definitions and pictures, things that can be very helpful for a translator, and is also doing an increasingly good job at spotting what we care about in terminology, which is multi-word units. So where you have production capacity, it recognizes that that's a unit and has the definition for that as a unit rather than two individual words. So a machine translation engine won't naturally necessarily know that that's a unit and should be translated as such. And we can go to that website and we can click on production capacity. Sorry. And it'll give us a definition, and it'll give us translations in different languages. And actually, interestingly, the translation in French is exactly the same as the one in Eurovoc. I don't know, Roberto could probably tell us if that's just accidental or that's a result of the work we're already doing with IATA, etc. But that marries up well. So it sort of confirms what we knew from Eurovoc. But this is a much broader resource, okay? So what we can also do is go along that sentence, and we also find helpful information on other multi-word units. So in that particular sentence, we were talking about chest freezers and microwave ovens. These aren't in Eurovoc. They're not core terms central to EU legislation, okay? But if you want to reuse this as a resource, it could be a term that would be useful in other applications of this as parallel text. And again, though, we start seeing some of the limitations then if we drill down. So if we drill down and look at what chest freezer tells us, it actually takes us to a more general definition of refrigerators, icebox, fridge. Okay, so we've already got a bit more general. If you just didn't know what a chest freezer was as a translator, you could go to this page and it would give you some information. But if you were relying on this to give you an accurate translation to use in an e-commerce website later on, well, you don't want to be ordering a fridge and or ordering a chest freezer and having a fridge delivered. That's not appropriate to that particular domain. So we can try and combine these resources, but we need to still include human validation. So this is the sort of thing we're looking at. We call it active curation in the LEADER project, where we try and build up, not only the positive validation of associations between text and terms, but the negative one. So we start off, if we follow our process, we start off typically, when we translate, we extract and segment content, get down to individual sentences. We can annotate it with terms that we know work well. So production capacity, it's Eurovoc, it's a well-defined translation. We know it was used in this particular case. So we can form a link between that terminology and that text and validate it. So that's a strong link, and we know where it came from. It came from Eurovoc. We can run the same sentence as we just showed through BabelNet and BabelFi. We can get some suggestions for what the concept's about and suggestions for what the translation might be. But that's all they are, is translations. So we have to deal with those carefully. So what we do is we say, well, we can take those, perhaps add a little bit, pinch of salt, and then run it through, use it to drive our machine translation engine. So we can take the term translations and force those multi-word units to be decoded in that way in a machine translation engine. So we'll get a translation that will respect that terminology, but we're not sure whether the translations of that terminology comes into place. So that's when we get to the post-editing. So this is where, again, the human validation is absolutely crucial. The post-editor will look at these and they'll say, okay, we don't use refrigerator in this situation, we're going to use another phrase, and he'll enter that. And we should have microwave in the plural here, so I'll change that as well. And what we do with the tools we have is we actually capture that back into the term base and then reflect that in a set of linked data. And what's important here is that there's value in here around the words and the terms that we know about already, but there's also value in the links. And by preserving those links, recording them, using linked data, being able to annotate who Craig came up with those links, and have they been validated and approved, or what status of authoritativeness are there, we can really start adding value to this. The nice thing about this is all of this seems, from the integration we've done today, all this seems to be very possible with existing standards from the W3C. We don't need to make up anything too new about it. So we're using an emerging standard called CSV on the web that allows us to use good old-fashioned tables and JSON, which nearly every sort of developer seems to understand very well. A few other W3C standards, JSON for linked data, the provenance vocabulary, and data catalog that Asun mentioned, open annotation, some ITS 2.0 data categories, and a few other ones that aren't in the W3 standards track that are being worked on actively. And it seems very possible to put these systems together without having to invent any new vocabularies, just actually following the guidelines from LEADER, which I think help a lot, and actually applying them in this situation. So still work in progress, but it's looking fairly positive. So I'll hand over to Andy to say a little bit more about the machine translation aspects of it.
Okay, many thanks, Dave. So what happened with FALCON is also we got ambitious, and I'll kind of explain where we try to push the boundaries out. But typically, where we have a language translation or language processing workflow, you start off with language workers, they build up information. That goes into language resource. That's used by language technology nowadays, like automated lookup of translation, etc. And the whole thing just is a very good cycle where everything improves over time. So what we've tried to do is to build on that. Now, one of the first aspects where we've tried to actually provide real improvements to machine translation using everything that Dave's explained so far is to work out, given an engine like Moses or CDEC, can we actually work out an optimal route for the translation? So rather than translate the project from start to finish, what if we can identify that if you do sentence 5, 150, 25, 30 in that way, will the translation improve the actual quality, productivity of the machine translation engine, will it improve over time? And we're seeing some very positive outcome of that. Researchers at TCD, specifically Alfredo Maldonado, who is responsible for the now famous Maldonado algorithm, which works out the optimal sequence. We're getting some very good feedback from that. But that requires that the machine translation, the whole translation process is within one integrated workflow. So some of the other things we've tried to do in terms of improving machine translation, as we know, statistical machine translation works off having big data, massive corpora. And what we do is we actually incant some spells, and the spells are called hidden Markov modules, Bayesian belief networks, or naive Bayes classifiers, etc. After incanting these spells, we kind of guess which words or phrases go which words or phrases. Now, instead of guessing, if we kind of apply massive bilingual dictionaries to the training process, then we should see quite a dramatic improvement in the quality of the machine translation. And that's being borne out. We're using BabelNet from Roberto Sapienza University for that, and things are looking really good. So this is actually the next aspect, having an integrated workflow for the statistical machine translation. So you don't just have a Moses engine on its own. You have a workflow within which all the bits are integrated. What we can do is, when we get a segment, we can identify terminology, and we can tell the statistical machine translation engine, you will use this terminology, and that's called force decoding. So rather than the SMT engine going out to its own tables, you tell it. Now, you can only do that if you've got it in a leader-like integrated workflow, and this is what we've built into the process. Next, it comes dynamic retraining, where we actually feed back constantly to the SMT engine everything that's going along. And then, obviously, as I mentioned in the previous slide, the actual optimal segmentation translation route from TCD, and at the end we can actually share that information. So it means constantly updating. Now, I'll run through this very, very quickly because we're almost out of time. As we know, all documents have a life cycle. Typically, that's how the life cycle looks. The differences that we bring with FALCON are that we actually add this in this central bit where we actually retrain, revise, annotate things, and then at the end we provide a complete, all-encompassing lexical concept life cycle as an overlay onto the translation process. So this is actually massive integration of various parts of translation to provide a much better statistical machine translation environment. In terms of systems integration, which is the final bit of FALCON, we have better context, in-context post-editing with XTM and EasyLing. We have feeding term suggestions from post-editor to the terminology management. That's XTM into verbum. We have dynamic retraining, bilingual dictionary SMT improvements, including BabelNet, named entity recognition, where we kind of identify things like names of companies, etc., and also that's handled automatically, what helps the statistical machine translation process. Post-editing prioritization, then publishing interlinks of parallel text, which is a very, very important thing afterwards, the curation part. And then very finally, but not least, actually timing or capturing the information on how long it actually takes how each post-editing step for each segment takes, and that's an important feedback loop. So thank you very much.
Thank you very much.